looking at today is this lovely graph, and this graph is the question we're asking, is this a function? So if we look at it and we think back to last week we talked about how functions have to pass the vertical line test. So if we look right in here, the question is, does it pass the vertical line test? I know I'm an awesome drawer with this thing. So right here, it seems like the line would cross one time. And right here, it also looks like it would cross. So technically, it looks like it doesn't pass the vertical line test. But there's a problem, or there's something that makes it okay. You see that open circle right there? Well, we know open circles means that it really doesn't equal the value at that point. So think of this as an eye of the needle. I can kind of take my vertical line and go right through it. It's not hitting, it's going right through it, and then it hits right there. So it actually only hits one spot on this graph. So this is a function. In fact, this is called a piecewise function, and that's what we're going to deal with today. You're going to take notes today as you go, and we will see where everyone's at the end, next class when I come back. So piecewise functions have several different things going on. If you look at this, it has a domain. So right here, it tells us for this part of the function, x is less than 0. So if we think about our table, we know x, y, we know x is less than 0. Now the problem is, if x is less than 0, it could be something really close to 0, like negative 0.0000. So I always put 0 in here, and I put an open circle around it to remind me that x is less than 0. Then I think, what are some other numbers that are less than 0? Maybe negative 1, negative 2, and everything's less than 0, so this can go on forever. Okay. So then, our function when x is less than 0 is x squared plus 1. So if I use the function, if I plug in 0, 0 squared plus 1 is 0, or 0 squared plus 1 is 1. Negative 1 squared is 1, plus 1 is 2. Negative 2 squared is 4, plus 1 is 5. And of course I note that this better look like a parabola when I graph it, because it's x squared. And so I put an open circle at 0, 1, and then negative 1, 2, and then negative 2, 5, and then I do my best parabola, and I'm using a slate, so it's rough. Alright, and so then, that's only half of my function. I also have x squared, or x is greater than or equal to 0. So for this part, I'm going to make another table, and this time I'm going to use values that are greater than or equal to 0. So I still include 0, and it can equal 0. So this time I draw a line under it, reminding me I'm going to color my circle in. So I have 0, 1, 2, 3, or anything greater than or equal to 0. And this time my function is x minus 1. So remember, this half tells me the domain, what I'm counting by, and this half shows me what I'm plugging it into. So this is y, remember, f of x is y equals x minus 1. So I have 0 minus 1 is negative 1, 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2. So I have 0, negative 1 with a closed circle, 1, 0, 2, 1, and 3, 2. And then I draw, and notice that one's a line, so it better look like a line. Well, as good close to a line as you can get it. So then let's come over here and answer these questions. So this says f of 1. Well, f of 1, 1's clearly greater than or equal to 0, so we're using that table, and we already know that when x is 1, y is 0. So we know f of 1 is 0. Same thing with negative 1. Negative 1 is clearly less than 0, so I'm going to use this table, and we already know that when x is negative 1, y is 2. This one's the trickiest one because 0 shows up here and here, but in order to do 0, we have to look at the second one because that's the only one that has a line under it. X is greater than or equal to 0, so we're going to use this one, so we know 0 is negative 1. I cannot write both answers. The only answer that has a closed-in circle is when x is 0, y is negative 1. So let's try just one more. So this one's a little different because this one says that x is between 0 and 3. And notice 0 has a line and 3 does not. So when I make my table, I'll put 0 with a line, and then x is between, so 1 and 2 is between, and then 3, I have to include it even though it doesn't equal it, I put an open circle. So then I have 2 minus 0 is 2, 2 minus 1 is 1, 2 minus 2 is 0, and 2 minus 3 is negative 1. So I'm plugging all of those x values into this equation. So I have 0, 2, and I have a line under it to remind me to close it, 1, 1, 2, 0, and 3, negative 1. And I have an open circle there to remind me to keep it open. And then I do the best job I can at making a straight line. That was pretty bad. Sorry, folks. And I'm not going to do it any better this time. So that's a straight line, just imagine. So then the next one is 3 to 5. We have x is between 3 and 5, so I'm going to put 3 with a line to remind me to color it in. 4, 5, and 5 also has a line to remind me to color it in. And this says that y, or f of x, equals negative 1. So that's going to mean that if x is 3, y is negative 1. If x is 4, y is negative 1. If x is 5, y is negative 1. So no matter where I have it on my x value, so x is 3, hey, wait, that colors in that open circle. Remember, that's okay as long as one's open and one's closed, then you're okay. So then you have 4, negative 1, and 5, negative 1, and you connect it, and that's our lovely function. It should kind of look a little bit more L-shaped than what mine looks like, because remember that black line's supposed to be a straight line, a diagonal line, and the red's also a straight, so it's kind of like a sideways L. Okay? So then, go ahead and pause me for a second. I want you to try this one, but I'm going to go ahead and do it for you. Go back, actually, wait a second. Go back and notice how this time I do not have any arrows because these have endpoints. We go 0, 3, so it's only between 0 and 3. And then 3 to 5, it's only between 3 and 5. So no arrows on this one. This one will be different because it's all numbers less than 2 and all numbers greater than or equal to 2. So go ahead and pause me for a minute and try it. I'm going to keep going just so you can check yourselves. Maybe. So here I am going over this now. You should have already tried it. If you did not pause me now. So x is less than 2. So I'm going to do 2, 1, 0. And then I plug in 2 to this equation. So 2 times 2 is 4, minus 4 is 0. 1 times 2 is 2, minus 4 is negative 2. 0 minus 4 is negative 4. 2, oh, and I forgot, that should have an open circle. So I should have one at 2, 0, 1, negative 2, 0, negative 4. And once again, I'm awesome at drawing straight lines. That one's a lot better than the last one, though. And then we have x is greater than or equal to 2. Now, I don't really like 3 in this situation because it's going to give me a decimal, so I don't have to go in order. So for example, here I could do 2, then 4, then 6. Doesn't really matter. I can do anything greater than or equal to 2. So if I plug in, I have to do the number that's here though. So 2 times 1/2 is 1, minus 1 is 0. 4 times 1/2 is 2, minus 1 is 1. 6 times 1/2 is 3, minus 1 is 2. So 2, 0, that's still okay. 4, 1, 6, 2, and I have another straight line. Now notice this time I have arrows showing that because this x is greater than or equal to 2, well, every number over here is greater than or equal to 2. Here I have an arrow because every number over here is less than 2. But in the middle, I cannot have an arrow because that's my boundary line. Some students try to put arrows in the middle, and that's wrong. That's bad. If you ever have something that doesn't pass the vertical line test, then it's not a function and you messed it up. So you got to go back and relook at this. So talk to each other, try the piecewise function worksheet, and when I come back next class, we'll talk about how you did. Alright, have a lovely day. Be good for the substitute. I'll talk to you later. Bye.